This is 7.6, finding general solutions using separation of variables and finding particular solutions using initial conditions and separation of variables. Let's take a look at reviewing what we call implicit differentiation. So what I want to do is I want to take the derivative with respect to x of both sides. So this is x squared plus y squared, and then take the derivative on the other side. Now remember, this is with respect to x, so this will be 2x. But remember, y is not an x, so we have to treat y as a differentiable function. So this will be plus 2y dy dx, and then this will be equal to 0. And if we want to solve for dy dx, you're going to take this to the other side, which will make it negative, and then that'll be an x, 2x, and then divided by 2y, so it'll be x over y. So this will be the differential equation. What we're going to be doing today is taking a look at implicit differentiation backwards. All right, let's take a look at dy dx. dy dx is the limit as delta x approaches 0 of delta y over delta x. We call dy a differential when it's just dy, and we call dx just a differential. So it's that small change in y and in x along the tangent line. Well, that's the way we're going to view these. We're going to view dy and dx as differentials. And what we want to do is we want to get all the y's to one side and all the x's to the other side. So the first thing I want to do is I want to multiply both sides by dx, differential x. So I'll have this. And the differentials will reduce. And now I have dy equal x squared times dx over y, and I want to get rid of that y, and I'll do that by multiplying both sides by y, and the y's will reduce, and now I have the separation. The y's are on one side and the x's are on the other side. At this point, I'm going to take the integral of both sides. And when I take the integral of both sides, I am going to get y squared over 2 plus a constant, and then I'll get x cubed over 3 plus another constant. And to make them look different, I'll put x sub 1 and x sub 2. All right, I'm going to bring the x's over to one side. This will be y squared over 2 minus x cubed over 3, and then I'll going to subtract the constant here. So this will be c2, take away c1. All right, and these are constants. So in the end, they really are just constants. So c squared over 2 minus x cubed over 3 equals c. We can just say c. We don't have to worry about the subscripts. Now this is called an implicit relationship. The x's and the y's are in this form. You could simplify it further if you didn't want any denominators. At this point right here, I'm going to deviate. I'm going to solve it a different way. So I'm going to do take the y to the other side. I'm going to take the c sub 1 to the other side. So I'll do c squared over 2 equals x cubed over 3, and then this will be plus c sub 2 minus c sub 1. And again, this is just some constant. I guess we could just call it c sub 3 when we put it all together. So I'll just erase it, and it's going to be a constant, and I'll just call it c sub 3. All right, now I'm going to multiply this side by 6. And then I'm going to multiply this side by 6 because I want to kind of solve for y. So then this is going to be 3y squared equals 2x cubed plus 6c sub 3. And this all will be a constant as well. I guess I could erase it and call it c sub 4 because it's still a constant. And this will be c sub 4. Okay, now I'd like to divide everything through by 3, so this will be y squared equals 2/3 x cubed plus, and dividing by 3 will create another constant, and I'll just call it c and not c sub 5, because really all of these are just constants. And if I want to solve for y at this point, I would have to take the square root of both sides. And taking the square root of both sides means that you'll have to plus or minus square root of 2/3 x cubed plus c. And so this would be the general solution. The plus c is showing you that it represents a whole family. And this is called an explicit form for y, where this is an implicit form for x and y. All right, let's take a look at doing this again, and I'm going to do the same thing. I'm going to get all the x's and y's on one side. So I'm going to multiply both sides by differential x, and then we'll have dy equals sine of x dx. And to get rid of the y squared, I'm going to, divide both sides by y squared like this. So now the y squares are going to reduce, and I'm going to have y to the -2 dy equals sine of x dx. And I'm going to go ahead and integrate, and then this will be, remember, upper power y to the -1 divided by -1 plus c. And then this will be negative cosine x plus and another constant, so constant 1, constant 2. All right, now I'm going to multiply I'm going to take that c to the other side. So this will be -1 over y equals negative cosine x. And then when I take this to their side, it'll be c sub 3. And I'm going to multiply everything through by -1. And so I'm going to travel up here. So multiplying this side by -1, multiplying this side by -1, and then multiplying this side by -1, I'll just create another constant, which I'll just call c. And at some point, I stop doing the sub 1, sub 2s, and I just call it constant because it just ends up being a constant. Now, to solve for y, what you can do is you can do the reciprocal of each side. So this will be y over 1, and then this will be 1 over cosine of x plus c. And it's really important that you understand the c is in the denominator. It's not just on the side. And so that is what we call the general solution. I want to remind you of an Algebra 1 topic, absolute value. When you have an absolute value equals to a number like 5, and you take the absolute value off, you need to understand that whatever's inside the absolute value can either be 5 or -5. And so you're going to get two solutions. And that's going to happen in this problem that's coming up. All right, so let's take a look at this. And what I want to do is get all the y's to one side. So that would mean dividing by y here. So this will be dy over y. Multiplying both sides by dx. So this will be secant squared of x dx. So I'm skipping some steps, hoping that you understand I multiply both sides by differential x, and I've divided both sides by that. So now at this point, I want to integrate. And now I'm going to have, this is a natural log of the absolute value of y. That's why I had to talk about absolute value, because we're getting an absolute value. And this is plus c equals 10x plus c. And I'm not doing sub 1 and sub 2. I think what I'll do is I'll just take the c to the other side, and we know we're going to have a constant. Let's not worry about subscripts anymore. Okay, now at this point, we have an initial condition. And with this initial condition, we are going to substitute. So this will be the natural log of 2 equals, and I don't need the absolute value, and then this will be tan 0 plus c. So tan 0 is 0, so this will be c is equal to the natural log of 2. I don't need that absolute value. So now I have the natural log of the absolute value of y equals tan x plus, and c is now the natural log of 2. Now, if I want to get rid of the natural log, I have to do what we call exponentiate. I've got to do e to this power right here. So this is natural log of absolute value of y equals e to the tan x plus natural log of 2. Now, e and natural log e undo each other. That's why I exponentiate both sides. So now we have absolute value of y, which is what I want. I want to get y by itself. And now on this side, I have e to the tan x, and you can say times e to the natural log of 2. You can use your exponent rules and separate it in this way. And so we now have the absolute value of y is equal to, and e and natural log of 2 will undo each other, and this will be a 2, e to the natural log of x. Now, when I drop y, I'm going to have plus or minus 2e to the tan x. Okay, now only one of these answers is correct, and it's the answer that's going to fit the point 0, 2. And so when you let x equal to 0, you have to get a positive 2. So the answer that we want is the positive form, e to the tan x, and this is the answer we want. We don't want the negative one, we want this one. And so that's our particular solution. All right, let's go ahead and do this one more time. We are going to find the general solution. Again, I want all the y's on one side, so I'll multiply each side by y times dy, and then multiply both sides by differential x, 2x dx. And I'm going to integrate both sides. This will be y squared over 2 plus c, and then this will be x squared plus c. And I'm going to take that other c and put it to the other side, so we'll just have a c. At this point, I'm going to use my initial condition to see if I can't find c. So this will be, I'm going to put a 1 in here, so this is 1/2 equals, and then I'm going to put a 2 in here, that'll be a 4 plus c. So c equals, then this is going to be -3.5 or -7/2. So this is -7/2. So now we have y squared over 2 equals x squared plus, or minus I should say, y squared over 2 equals x squared minus 7/2. All right, and I'm going to multiply everything through by 2, so this is y squared is equal to 2x squared minus 7, and then when I take the square root of both sides, this will be plus or minus root 2x squared minus 7. And which one are we going to want? We're going to want the one that yields a positive answer, because when I put 2 in here, that's going to be 8. 8 take away 7 is 1, and I want a positive 1. So I want this answer right here, 2x squared minus 7. This is the answer I want. And what does it look like in the slope field? Remember, the point is 2, 1 right here. And so what it is, it's this part right here. Actually, the whole thing is actually a hyperbola, but we don't want the lower half here because we don't want our y's to be negative.